Welcome to Little Magic Adventures, everything you missed today in 15 minutes. It's amazing, isn't it? How we've looked up at the sky for, forever, just wondering what's out there.
Totally. And it turns out there is pretty darn big. We're talking galaxies, right?
Exactly. Galaxies. Those swirling masses of stars, gas, and dust. Billions, trillions of stars in each one. Mind-boggling.
It really is. I mean, you hear billions and trillions thrown around, but can you even picture that many stars?
Not really. The narrator mentions how intriguing these swirling islands of stars are. I love that phrasing, swirling islands. It captures the vastness and beauty, doesn't it?
Yeah, like each galaxy is its own little universe, almost. So how big are we talking here? What's the biggest one?
Well, for a long time, the champion was IC 1101. This huge elliptical galaxy, basically a spherical ball of stars.
Elliptical, not like our Milky Way, right?
Nope, ours is a spiral. IC 1101 was estimated to be around 4 million light years across. Think about that for a second. 4 million light years.
That's insane. Our Milky Way is only, 100,000 light years across?
Right. 100,000. Makes us look kind of puny, huh?
Just a little. The podcast said it would take 155 million years in our fastest spacecraft just to cross the Milky Way. Imagine IC 1101.
Billions of years. Billions with a B. It's home to something like 100 trillion stars.
100 trillion? Compared to our measly few hundred billion? We're practically a speck of dust.
Yeah, pretty much. IC 1101 was the king for decades, the undisputed heavyweight champ.
But there's always a bigger fish, right?
You know it. In 2022, a new contender emerged. Alcyonius.
Alcyonius? Is that even bigger than IC 1101?
Well, it's complicated. See, IC 1101 is largest based on where its stars are, its stellar extent, but Alcyonius wins in the radio emissions category.
Radio emissions? What does that even mean?
So these giant radio galaxies have these massive jets coming from a supermassive black hole at their center, and these jets produce radio waves. Alcyonius's radio emissions stretch out a mind-blowing 16 million light years.
16 million? That's 4 times larger than IC 1101's stellar extent. The podcast even mentioned 230% larger than IC 1101's end-to-end measurement. That's massive.
Absolutely massive. That makes Alcyonius the largest known galaxy by its overall radio emission size. It really changes how we think about galaxy size.
Yeah, it's not just about the stars anymore. This whole radio emission thing adds another layer of complexity. It's like trying to measure a cloud.
It is. It's like, where do you even say it ends? Galaxies don't have clear edges. They sort of fade out into space. The podcast talked about that, how different ways of measuring will give you different sizes.
That makes sense. So who knows? Maybe there's something even bigger out there than Alcyonius, just waiting to be discovered.
So, we were talking about these massive galaxies, right? Like IC 1101, 4 million light years across. It's unbelievable.
I know, right? It makes our Milky Way look like, well, not so milky, more like a drop of milk in a cosmic ocean.
Exactly. 100,000 light years versus 4 million, we're talking 40 times bigger.
Yeah, and the narrator pointed out that it's elliptical, not a spiral like ours. So it's like this giant ball of stars.
A giant, ancient ball of stars, probably full of red giants and who knows what else.
Right? It's just out there, silently existing. I mean, if you could see the whole Milky Way, then IC 1101 would extend as far as across 40 Milky Way disks laid next to each other.
It's hard to even comprehend. It's a good thing there are diagrams and illustrations in the episode.
Yeah, definitely. You know what's even crazier? The time it would take to cross it?
Oh? Don't tell me. Millions of years? Billions, probably. In our fastest spacecraft. Just to cross our own galaxy would take, what do they say, over 150 million years? Something like that. So IC 1101, forget about it. You'd need like a warp drive or something. Ha! Yeah, or a really, really long lifespan. So we were talking about these massive galaxies, right? Like IC 1101, 4 million light years across. It's unbelievable.
I know, right? And 100 trillion stars? I can't even, our Milky Way is like a little toy next to it.
Totally. A drop in the bucket, cosmically speaking. Remember what the narrator said? Just to cross our own galaxy would take like 155 million years at our fastest speed. Imagine IC 1101.
Billions of years? Easy. You'd need a serious upgrade from our current tech. Maybe a warp drive, like in
Star Trek. Yeah, or maybe just a much, much longer lifespan.
Right, like elf-level lifespan. But then there's this Alcyonius, that's the new kid on the block, right?
Yeah. 2022, the new heavyweight champion, potentially. It's complicated.
Hmm. Complicated how?
Well, see, IC 1101 is still the biggest in terms of where its stars actually are. It's where they call it stellar extent.
Right, stellar extent. So like edge to edge where the stars are hanging out. Got it.
Exactly. But Alcyonius is different. It wins in the radio emissions category. Giant radio galaxy, they called it.
Radio emissions? So not just the stars themselves, but something else?
Yeah, these massive jets shooting out from the center, from a supermassive black hole, no less. And those jets, they produce these huge radio waves.
And those waves, they extend way beyond the stars, right? Making it seem even bigger?
Exactly! Alcyonius's radio emissions stretch out, wait for it, 16 million light years. That's 4 times bigger than IC 1101's stellar extent.
16 million? Whoa, that's mind-bogglingly huge, even bigger than...
Than IC 1101, in that specific way. The narrator made a point of clarifying that. It's not just about the stars anymore, it's this whole other way of measuring galaxies.
It's like trying to measure a cloud. Where does it begin? Where does it end? It's all kind of fuzzy, right?
It's like we're talking about 2 different ways of measuring a galaxy, right? With IC 1101, it's the stars themselves, the stellar extent.
Yeah, like where the stars actually are, edge to edge. Makes sense.
But Alcyonius, it's these radio missions, these jets shooting out, and they're huge.
16 million light years. The podcast said it's like 4 times bigger than IC 1101's stellar extent, 230% larger than IC 1101's end-to-end measurement. That's a whole different level of big.
It's almost like, imagine a tiny bright light bulb that's IC 1101 based on its stars.
Okay, yeah, I'm following.
Now imagine that same light bulb, but with these beams of light shining out in opposite directions. Beams that stretch out much farther than the light bulb itself. That's Alcyonius.
The light bulb is the stars. The beams are the radio.
Emissions, exactly. And those beams, in Alcyonius's case, are ridiculously long. 16 million light years. Driven by a...
Supermassive black hole at its center.
Right. That's powering these jets, these massive plumes of energy. It's like a cosmic lighthouse almost.
A lighthouse with beams 16 million light years long? That's... wow. It makes IC 1101, which is already massive, look almost small.
Well, smaller in a certain way. I mean, in terms of where the stars are, IC 1101 is still the champ. But this whole radio emission thing, it adds another dimension to how we think about galaxy size, doesn't it?
Absolutely. It's like you can't just look at the visible stuff anymore. You have to consider the invisible too, the energy radiating out.
It really changes the game. It's not just about counting the stars. It's about the whole picture. And Alcyonius, in that picture, is a giant.
A giant with invisible arms reaching out millions of light years. That's a pretty awesome image.
It's like we're not just talking apples and oranges anymore. We're talking apples and like giant cosmic nebulae or something.
Huh. Yeah, exactly. It's like, how do you even compare? It's not a straightforward bigger or smaller anymore.
Right? So Alcyonius, this giant radio galaxy, it's the biggest in a way, but not in every way.
Yeah, the biggest by its radio emissions, like the biggest invisible galaxy. Is that even a thing?
Well, the emissions aren't invisible. They're just not visible light. They're radio waves, which I guess are invisible to our eyes, but...
But we can detect them with radio telescopes, right? So it's like it has this huge invisible halo or aura.
Yeah, something like that. 16 million light years across? That's what makes it the biggest in that specific way. The narrator was very clear about that, right? It's a specific measurement.
Right. It's not like it's the biggest clump of stars. That's still ISIL 1101, right? 4 million light years of stellar extent, which is still massive.
Totally massive. But Alcyonius has these jets, right, shooting out from its center, driven by...
A supermassive black hole, of course. It's always a black hole with these things. And those jets create the
radio emissions, exactly. And those emissions, they stretch out way beyond the stars of the galaxy, like way beyond.
16 million light years beyond. That's like 4 times bigger than IC 1101's stellar extent, 230% larger, like they said.
It's mind-blowing, isn't it? The scales we're talking about here, it's almost impossible to grasp. Like, what is a million light years anyway? Never mind 16 million.
I know, right? It's just numbers. Big numbers, but they don't really mean anything to our little brains.
The narrator mentioned this, about the challenges of measuring galaxies, right? They don't have clear edges.
Yeah, they're fuzzy, like cosmic clouds. Where do they begin? Where do they end? It's all kind of blurry.
Exactly. So measuring them, it's tricky. You can measure the stars, the stellar extent, like with IC 1101.
Or you can measure these radio emissions, like with Alcyonius, and you get a completely different answer.
A much bigger answer. 16 million light years. It's like it's rewriting the rules of what big even means in the universe.
It makes you wonder what else is out there lurking in the darkness. Even bigger than we can imagine, right? With even bigger invisible arms.
So it's like we're constantly learning new things, right, about the universe, about how big things really are.
Yeah. It's like the goalposts keep moving. What we thought was the biggest turns out maybe it's not. Maybe there's something even bigger lurking out there.
Like Alcyoneus. It blew everything we knew out of the water. 16 million light years? It's ridiculous.
Totally. And it's not even the stars themselves, it's those jets, right? Shooting out from the center.
The radio emissions. Powered by that supermassive black hole. It's like a cosmic lighthouse, but on a scale we can't even comprehend.
And IC 1101, it was the chant for so long. 4 million light years across, just the stars? And now, it's not even close.
Well, it's still massive. Just not in the same way. It's like comparing a basketball to a giant nebula or something.
Ha! Yeah, they're both big, but in totally different ways. So Alcyoneus is the biggest, in a way.
Right? The biggest by its radio emissions. 16 million light years. It's almost like cheating, right? It's not the galaxy itself, it's these invisible arms reaching out.
Invisible, well, not really invisible. We can detect them, right, with radio telescopes. It's just not visible light.
Yeah, it's like this huge invisible halo. Or an aura, something like that, 16 million light years across.
So, what's next? What's bigger than Astronomy? What's lurking out there in the darkness?
Who knows? That's the exciting part, right? There's always something bigger, something more mind-boggling, waiting to be discovered.
The narrator, they said it best, I think. The quest to find the largest galaxy continues. It's like a never-ending story. The universe is vast, and we're still just scratching the surface. We are so tiny in comparison, and we don't even have clear ways to measure the universe and its galaxies. They don't even have clear edges, right?
It's true. And as our telescopes get better, as our understanding grows, who knows what we'll find? What new giants will emerge from the darkness? What new ways of measuring the universe will emerge from the minds of our scientists?
It's humbling, isn't it? And awe-inspiring to think about the sheer scale of it all. And we are part of it all.
It really is. Thanks for joining us on this cosmic adventure. It's been a mind-expanding journey, exploring the vastness of the universe and the incredible sizes of these galaxies. Until next time, keep looking up at the stars and wondering what else is out there. This is signing off, reminding you to embrace the mysteries of the universe. Goodbye!
And this is reminding you there is always more out there to explore and discover beyond our imagination. Keep wondering, friends. Stay curious. And until our next little magic adventures, keep exploring the universe, one podcast at a time.